2.5D. Let's have a look. One about bank question. Jerry deposit $30,000 in a bank at the beginning of each year. Oh, deposit each year, the beginning of each year. Okay, starting from this year at an interest rate of 0.25% per annum compounded yearly. Okay, understand the question? Okay, part A. Find the amount obtained by Jerry at the end of the 10th year. Here, beginning of each year, at the end of the 10th year. That means about the 11th year, not include this $30,000, but it completes one period. Understand? So let's see. Each year deposit $30,000 each year. So let's see. Think about it. At the end of first year, what happened? Actually, the amount is $30,000 times 1 plus 0.25%, right? So you can write as $30,000 times 1.0025 like this. How about at the end of second year? How about at the end of second year? Okay, it's better for you to write it down clearly. This one, $30,000 plus $30,000 times 1.0025, all together times 1.0025. Okay? And you ask me, why become like this? After the end of the first year, you get this amount. That means this amount. And start from the second year, okay, you have one more year at the end of second year. So this one plus the deposit of the second year. This one is the deposits of the second year, right? Okay, so total amount times this year. Understand? So you get this one. Oh, sorry, one more zero. 1, 2, 3, 4. Okay, this one times 1.0025, and then plus this one 1.0025 to the power 2. This is the end of the second year. You get this amount. Okay, maybe I write one more. At the end of third year. What do you think? Amount equals, okay, 30,000 times this one, 30,000 times this one, and all together run one more year. Run one more year, so times this one. This is the total amount of the third year. And oh, sorry, I used this one. Second year, you get this amount, right? Then this one is the deposits of the third year, because each year at the beginning we deposit, Jerry deposit $30,000. So you get this one as the beginning of the third year. Then after that, one more year times 1.0025. You get this one. So the amount becomes this one. This one times 1.0025 plus 30,000 times 1.0025 to the power 2. 30,000 times 1.0025 cube. Clear? Okay. The question asks you at the end of the 10th year. What do you think? Yeah, not difficult, right? The amount equals 30,000. Okay. Times, okay. Maybe I can write it like this. This one. 1.0025, 30,000, 1.0025, and then dot dot dot. Third year up to power 3. So this one 30,000, 1.0025 to the power 10, right? That's great. Yeah. Then what can we do? Okay, I pick up this one. This is the first term, and this is the last term. First term, last term. Okay? So this one times 1.0025, okay? Altogether times 1 minus 1.0025 to the power 10, right? Right? This one is R, 1 minus R. Okay? So at the end, this one $304,156. This one correct to nearest dollars. Okay? So you see that about the compound interest, we need to write it carefully, because this time every year Jerry deposit $30,000 in the bank at the beginning of each year. So each year deposit $30,000. So after first year, calculate it. After second year, after third year. Then look at this three different sum. That means the amount. And you found that this is a geometric series, right? So at the end, up to 10th year, make use of the formula and you can find the sum of the amount of the money. Okay? Part B. Part B. At least how many years later will the balance of his account exceed $900,000? You see, after 10 years, you get $304. Then how many years later you get exceed $900? At least how many? Okay, so maybe I write as at the end of nth year. What is the amount? Yeah, just now write as 10 years. So this time not difficult. 30,000, okay, times 1.0025 and then times 1 minus 1.0025 to the power n, all together over 1 minus 1.0025. Right, this is the amount. So this one, okay, I pick up $30,000. You need to check this one greater than $900,000, right? So simplify this one. (1.0025) minus 1.0025 to the power n, and here negative 0.0025 greater than 30, right? Here n plus 1, sorry. So after simplify, I write faster. This one becomes 1.0025 to the power n plus 1, okay, greater than 1.00775. Okay, I take log on both sides. Okay, so n plus 1 greater than this one. And you found that this one n greater than 28.89. Okay, so the balance of his account ACCOUNT, well, exceeds $900,000 at least how many years? Yeah, 29 years. Okay, 29 years later. Okay, so just make use of the formula and then check this formula or this amount greater than $900,000. Afterwards, simplify and become this. This part or this step, up to this step, please do it carefully, okay? And you found that this one. This time, log greater than 1, so it's positive. No need to change the sign. Remember, this time no need to change the sign because this one is positive at the end, n greater than this value, and find the correct years, at least 29 years. Okay.